Let's start on this page. First, we need to calculate the mean age of the population. We can calculate the mean age of the population by adding the 4 ages and dividing the total by 4. If you add these 4 ages and divide the total by 4, you get 20. So the population mean, or mu, is 20. Next, we need to plug the ages into the 6 possible samples of 2 people. Person 1 is 10 years old, person 2 is 20 years old, and so on. After we plug in the ages into all 6 possible samples, we need to calculate the mean of each possible sample. We can calculate the mean of each possible sample by adding the 2 ages in the sample and dividing the total by 2. Let's start with sample 1. 10 plus 20 is 30. 30 divided by 2 is 15. So the mean of sample 1 is 15. Let's move on to sample 2. 10 plus 20 is 30. 30 divided by 2 is 15. So the mean of sample 2 is 15. We just need to do this 6 times, one time for each sample. The symbol for sample mean is x bar, so we're calculating 6 different x bars. After we calculate the 6 sample means, we list them out in this column that says sampling distribution. After we list them out, we calculate the mean of the sampling distribution. We can calculate the mean of the sampling distribution by adding the 6 sample means and dividing the total by 6. If you add these 6 numbers and divide the total by 6, you get 20. So the mean of the sampling distribution, or mu x bar, is 20. So the symbol for population mean is mu, the symbol for sample mean is x bar, and the symbol for the mean of a sampling distribution that's made up of sample means is mu x bar. Let's move on to the next page. On this page, we're going to plot the 6 sample means that we just calculated. First, let's write the population mean, or mu, right here. You already know that it's 20, because we just calculated it. We're going to plot the 6 sample means, or the 6 x bars, in this graph right here. The mean of sample 1 was 15, so x bar 1 is 15. The mean of sample 2 was also 15, so x bar 2 is 15. The mean of sample 3 was 20. The mean of sample 4 was 20. The mean of sample 5 was 25. And the mean of sample 6 was 25. So these are just the means of the 6 samples. 1, 2, 3, 4, 5, 6. After we plot the 6 sample means in this graph, we do some labeling. I'm just labeling that 15 and 25 are the 2 most extreme sample means in the sampling distribution, because they're the 2 sample means that are furthest from center. After I do that, I'm labeling the probabilities of the sample means. When a sample of 2 people is randomly selected from this population of 4 people, there's a 2 out of 6 chance that the sample mean will turn out to be 15, because 2 of the 6 possible samples have a sample mean of 15. There's a 2 out of 6 chance that the sample mean will turn out to be 20, because 2 of the 6 possible samples have a sample mean of 20. There's also a 2 out of 6 chance that the sample mean will turn out to be 25. And I also said that you're going to be selecting your own actual sample of 2 people from this population. You'll do that by getting 4 pieces of paper and writing 10, 20, 20, and 30 on the 4 pieces of paper. After that, you'll draw 2 pieces of paper randomly without looking, and that'll be your actual sample. Let's say that you end up getting person 1 and person 2 as your actual sample. You would just put their ID numbers right here, 1 and 3. And you would also put the mean of your actual sample right here. If you ended up selecting person 1 and person 3 as your actual sample, that means that you've selected sample 2. And the mean of your sample is 15. So if you selected person 1 and person 3, you would put 15 right here as your sample mean. You would also circle x bar 2 to show that the mean of your actual sample was this sample mean right here. It was the mean of sample 2. Down here, we're just saying that the population mean is 20, and the mean of the sampling distribution is 20. You already calculated these numbers. And after we do that, we're finished with this page. Let's move on to this page. First, we need to calculate the mean of the population. The four numbers are the same, so the population mean is still 20. Next, we need to plug the ages into the four possible samples of 3 people. After we plug in all of the ages, we need to calculate the mean of each possible sample. We can find the mean of each possible sample by adding the 3 numbers and dividing the total by 3. Let's start with sample 1. 10 plus 20 plus 20 is 50. 50 divided by 3 is 16.7. Now let's try sample 2. 10 plus 20 plus 30 is 60. 60 divided by 3 is 20. We just need to do this 4 times, 1 time for each sample. Once we get the 4 sample means, we list them in the sampling distribution column. After that, we calculate the mean of the sampling distribution by adding the 4 numbers and dividing the total by 4. If you add these 4 numbers and divide the total by 4, you get 20. So the mean of the sampling distribution is 20. Let's now move on to the next page. On this page, we're saying that the population mean U is still 20 because it's still the same 4 ages up here. We're plotting the 4 sample means that we just calculated in this graph. The mean of sample 1 was 16.7. The next 2 samples both had a mean of 20, and the 4th sample had a mean of 23.3. So these are just the means of sample 1, 2, 3, and 4. After we plot the 4 sample means, we just labeled it 16.7 and 23.3 are the 2 most extreme sample means because they're the furthest from center. Next, we plot the probabilities of the sample means. When a sample of 3 people is randomly selected from this population, there is a 1/4 probability that the sample mean will turn out to be 16.7 because one of the 4 samples has that sample mean. There's a 2/4 probability that the sample mean will turn out to be 20 because 2 of the 4 samples have a sample mean of 20. And there's a 1/4 chance that the sample mean will come out to 23.3. After that, we just write the population mean 20 and the mean of the sampling distribution, which is 20. We calculated both of these on the last page. This is just saying that the mean of the 4 population members up here is 20, and the mean of the 4 sample means right here is also 20. After that, you need to select your actual sample of 3 people. To do that, you just take the same 4 pieces of paper with an age on each one, and you randomly draw 3 out of the 4 pieces of paper. Those 3 people will be your actual sample. Let's say you get person 1, person 3, and person 4. You would put their ID numbers right here, and then you would put the mean of your actual sample right here. If you selected these 3 people, your sample mean would be 20 because these 3 people have a mean of 20. You can see that that's In sample 4, 0 males divided by 2 is 0. And the same thing happens in sample 5 and sample 6. Once we calculate all 6 sample proportions, we list them out right here in the sampling distribution. And then we calculate the mean of the sampling distribution by adding the 6 numbers and dividing the total by 6. When you add these 6 numbers and divide the total by 6, you get 0.25. And we're finished. So on this page, P is population proportion, or the proportion of males in the entire population. P hat is sample proportion, and U P hat is the mean of a sampling distribution that's made up of a bunch of P hats. Let's move on to the next page. First, we need to write the population proportion, or P right here, which we know is 0.25. The population is 1/4 male. Next, we plot our 6 sample proportions right here. The first 3 samples were all 0.5 male, so P hat 1, 2, and 3 are all 0.5. The last 3 samples were all 0, all had 0 males, so P hat 4, 5, and 6 are all 0. These are just the P hats of the 6 samples, 1, 2, 3, 4, 5, 6. After we plot them here, we're just going to do some labeling. 0 and 0.5 are the most extreme sample proportions because those are the only 2 possibilities in this case. Down here, we're going to plot, we're going to write P, which is 0.25, the population proportion. Also the mean of the sampling distribution, which came out to 0.25. The mean of these 6 numbers up here is 0.25. Next, you're going to get 4 pieces of paper and write M, F, 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 and then randomly select 2 of the 4 people to be your actual sample. If you end up selecting person 1 and person 2, you'd write 1 and 2 right here. And then you're going to write the proportion of males in your actual selected sample. If you end up selecting person 1 and person 2, you've selected sample 1, which is 0.5 male, which means your P hat is 0.5. And right here, you'll circle P hat 1, because that's the P hat of your actual sample. This is your selected sample right here. And also, you'll check with 2 other classmates and see what samples they got. Let's say one of your classmates gets sample 3. You put a tick mark here, because that's their outcome. Let's say that another classmate, your other classmate, gets sample 4. You'd put a tick mark here to show that that's their outcome. So you're circling your outcome and putting tick marks next to the outcomes of 2 classmates. After that, you're finished.